I am Tanuja and today we are going to learn one of the concepts of chemistry. So for next few minutes we will explore the topic of types of cleavages of covalent bond, namely homolytic cleavage and heterolytic cleavage. So to make this topic more easier to understand, I am going to differentiate between homolytic cleavage and heterolytic cleavage. We have criteria of 6 points. So our first point to differentiate between homolytic cleavage and heterolytic cleavage is definition. So what is homolytic cleavage? In a covalent bond comprises two electrons shared between two bonded atoms. So in homolytic cleavage, the electrons, both the electrons go to one of the bonded atoms. Now I'll explain it with an example. When A is bonded with B, one electron goes to A and the other goes to B, which results in free radicals. On the other hand, in heterolytic cleavage, both the electrons go to any one of the bonded atom, which means when A and B are bonded, we get two charged species plus B negative. Our second point to differentiate between homolytic cleavage and heterolytic cleavage is representation. Homolytic cleavage is represented by single-headed arrow, which is also known as fish hook, and heterolytic cleavage is represented by double-headed arrow. Our third point is product. So when homolytic cleavage takes place, we get products as free radicals, and in heterolytic cleavage we get ions, means two charged species in which one is positive and the other is negative. Our fourth point of differentiation is favors in. So favors in means are likely to happen in which condition. So homolytic cleavage is likely to happen in high temperature, UV light, H2O2, which is nothing but hydrogen peroxide, and non-polar solvent. And heterolytic cleavage is likely to happen in low temperature and polar solvents. So our fifth point to differentiate between homolytic and heterolytic is reaction name. So we have a trick here to remember these names from point 3 and point 4. So reaction mechanism name for homolytic cleavage is free radicals reaction, is also known as free radical reaction, or non-polar solvents reaction, non-polar reaction. And heterolytic cleavage is opposite, ionic reaction and polar. So our fifth point, to again classify them, sixth point is examples. When CH3 is bonded with Cl, methyl is bonded with chlorine, one electron goes to Cl and the other goes to methyl. We get when the homolytic cleavage takes place, we get methyl free radicals and chlorine radical. On the other hand, when heterolytic cleavage takes place, is bonded with Br, one of the electron goes to Br and we get two charged species in which one is positive and the other is negative. In this case, Br is most electronegative than methyl. So this was classification of heterolytic and homolytic and heterolytic cleavages.